So hi everyone, and we are going to discuss this problem string matching in an array. I have already posted a video regarding the brute force approach. In this video we are going to talk about the optimized approach, and this optimized approach uses the data structure called trie. So what is a trie? Like if you're given a group of strings and the length of the longest string is O of m, so you can search a particular string in the data structure in O of m time. Okay, so what we are going to do in this problem, we are going to take this array of words, and for each word we will find all of its substrings. So in total number we will have O of n into m square substrings, and we would construct a trie using these substrings. Now for each word we can check if that word is present in the trie or not. If it is present, then we could include that in our answer set. Also, it won't be that easy. The not only the word substring, but the word itself would also be present in that. So we will also have to take care about it. So it is a little bit of try plus some modification you have to do in it as well. So how we are going to do it? Before moving forward with this video, you need to understand the concept of try, like what is try and how it is like visualized. You could read it from Geeks for Geeks, or you could read it from CP algorithms. I won't be able to do that here because I can't draw anything on the screen right now. I don't have the equipment. I could just code. So I'll just tell you, like if there's a string called a and d, so and a and t, so try will be something like a, then n, then d, and from n there can be some other branch as well, like this one. This branch will point to t. Okay, and a is the starting, and we also want to know that at this character this word ends. So at d the word ends, so we could mark it with star. At t the word ends, so we could mark it with t. And this is also starting from somewhere. Suppose it was starting from here, from this dot, and you have some other word as well. You can say did and do. So you can have d, then you can have I, then you can have d, and you can also have o. So see, all the words, this is the root, this dot is the root of the tree. Okay, so if you want to search do, you can just go to d and you can then go to o, and this star represent that this word ends here. Okay, so the characters which are marked with star are called terminals. They indicate that this is the end of a word. Okay, so it's just a tree with a rooted at dot. So each node of this tree is a vertex, and it contains two information. One, first, that is this a terminal node? Like, is this the node where the word ends? And it also stores the pointer to the next node. So in one vertex, at how many maximum locations it can go? If you're talking about all the lowercase strings, then there could be 26 cases possible. So the second information the node will have will be an array of 26 characters, and that will store that after this character to which node we have to go. Like after traversing a, to which node we have to go. Like some word can be adb as well, so from a there would be other branch to d as well. So after A, where we want to go. So that array will store that information. So this is how this problem like tries are created. For this particular problem, we are not interested in the terminal node because we don't need to know that where the word ends. What we want to know is uh, like how many substrings are there. Suppose like we are going to store the frequency of each character with that, and like this character, this some character of how many substrings it is part of. Like if there is stored 2 with n, so we are saying that of how many substrings n is a part of. Okay, so and not n, technically string an is part of, or if it, I is with 3, so we can say that di string is part of how many strings. Okay, di is substring of how many strings, so 3 strings, something like that. So how are we going to do that? First we will create, I know it's a bit difficult to understand. You should visit CP algorithm, like they have described it nicely. So the code will be something like this. Like after understanding the data structure, you will be able to understand what I'm trying to do here. So this is the node, and it will store the next, and next will be uh, these are 26 characters. A is mapped to 0, B is mapped to 1, something like this. And this array will store the address to the next node, like in A and D. After A, where we want to go, to N, to B, or where. Okay, and we have some frequency. You can also create a constructor to initialize these values. For next, you can initialize it with -1. And for frequency, you can initialize with 0. Okay, now when I created a diagram, there was dot. So that dot is also a vertex. Like there are so many strings. It is not necessary that every string will start with the same character. They can start with any character. So from dot we will go to that first character. Like we had some strings that starts with A and an ant, and we had some strings that start with D, did and do. So that dot will point to A and D. So that dot is also a node of the tree, and it is the root. So we are going to create a try vertex, and its size will be 1. This, so it has one node, and this one node shows that that dot. So now we are going to traverse all these words. So I'm going to traverse this word array. Now we have the word. Now we want to traverse all the substrings of this word, because we want to fill this try with all the substrings. So what I'm going to do is I'm going to calculate the size of this word first. And now I'm going to traverse all the substrings. And now we will start from the root node. And yeah, wait. Okay. Like from here we will get substrings like this: 0, then 1, first 0, then 0 1, then 0 2, then 0 3, then 0 4, something like that. Okay, so what we are going to do is we will take a vertex, like we have, v0 represents the dead dot node, Okay, and we are going to get the character at this jth position. So what is the character? C and word of j minus a. So this is the character. Now we are going to check if this character is already present in try. Technically we are checking that if this word j is already present in try or not. So how are you going to check that? If this character is not present, then it will be -1. So what should we do? We should add this character there. So what we are going to do, we are going to create a new node to which this character is pointing to. So I'll add right now the size of the try is 1. So I will add uh, right now the size of the try is 1. Therefore there is only one node with index 0. Right now what I've pointed this character to try.size. So it is pointing to 1, which is the index of the next node 1. And I also going to increase the size of the try. So now it has 2 elements, and the node v0 with some character is pointing to that first index node, and then we can move to that node. So this is how we are going to create the try, and we are also going to update the frequency, like to which character it is going. So this is the character, this is the node to which we are going. Try v dot next c, and the next of this we will update the frequency. Okay, so this is how our try will be created. So you can see that this loop will take O of n time, this loop will take O of m time, and this loop will also take O of m time. After this we could just pick each word and check if it is if that word is present in the try or not. So how are we going to check it? We are going to pick that word, then in a similar way we are going to search that word, and this is how we are going to search same way. And if that character is not present, then it means that this word is not in the try. So we could break the loop, otherwise we could update and go to the next character. So this is how we are going to move. And while doing this, when we come outside, if it breaks, uh, so yeah, if it breaks, then then that word is not present. So we are also going to check here if whatever vertex we have come upon, finally, if that vertex frequency is greater than 1. If it is a frequency 1, then technically that word is only there. But what we want, then this word should be a part of some other substring as well. So if that word is only there, then its frequency will be 1. But if it is also part of some other substring, then its frequency will be greater than 1. So here we could push that word in the result array like this, and finally you can return the result. So this is how I think this must work. Okay, I'm getting a compile time exception. Why? Okay, it is try. So it is accepted. This frequency thing is, I'm going to explain it to you again. Uh, like, like if uh, there is a string called, in this example only, there's a string called mass and there is as. So one one string in the try would be mass, then other string will be ass, then other string will be s. Okay, so ss. So for when we are going to encounter as, then there will be one more string that is formed, that is as. But for the next substring s, there would already be present substring which was coming from mass. I mean like this. From that dot node, you will have, you're going to store every substring of mass. So if this is the dot node, you will have mass. Then from that dot only you will have ass as well. From that dot only you will have because ss, because you are storing all the substrings. Now there is one more substring of mass, that is single s, but you won't create separate node for it because this node is already there. It will check here only. Okay. Similarly, when you will try to create for as, it will go for this one. And from that as there is one more substring s, then it will go for this one. So when you're again going through this, you could just increase the frequency. So you can say that there is one substring of s. Like these characters are coming 2 times. Okay. Uh, in once in ass and once in as. So that is what I'm trying to do. If you don't still don't understand, you can comment and I'll reply you at that comment. Okay. This is accepted. And you can see that the time complexity of this solution is O of n into m into m. So thank you for watching this video. Subscribe and hit the bell icon to receive notifications.